Hello, today I'm going to talk about the main clock output and how to use it to measure the clock frequency. So first of all, what is the main clock output? The main clock output is a pin that can be used for measuring the clock frequency. For example, here in the clock tree diagram, we can see that we are able to output the PLL, HSI, HSC, and system clock. The system clock does not have a value by itself. The system clock will have the value that we choose. For example, we can choose the HSI, PLL, and HSC to be the clock for the system clock. So if you want to output the system clock in the main clock output, we need to change the clock source. And in this case, we are not going to do this because we are going to measure the clocks without changing the clock source. So now we have these three options. The HSC, which is the high-speed external, I will not use it because I don't have a external clock soldered on my board. That's why I will only use the PLL and HSI. So now let's go to the code. All the values that I have here I took from the reference manual of my microcontroller. Now the next thing is to identify which pin in our microcontroller the main clock output is. In my case, the main clock output is connected to the pin A number 8. And also this pin can have more functions like timer and the clock for the USART. So this means that we need to choose which function we are going to use in this particular pin. Then we need to set this pin as alternate function, push-pull mode, and also to be able to use that port, we need to enable the clock for that peripheral. So these lines can do the job. So now we need to select which clock we want to output in the main clock output pin. So let's start by outputting the clock frequency for the HSI. And remember that all these values I took from the reference manual from my microcontroller. Then I advise you to look at your reference manual from your microcontroller to check if these values correspond to your microcontroller. So after this we can compile and flash. So here I have the result from the main clock output showing the HSI frequency, which is 8 megahertz. And here in the oscilloscope you can see that we have this frequency. Now let's output the PLL clock. And for this, we need first choose which clock will feed the PLL clock. So for this, let's say that we are going to use the HSI clock. By default, the HSI clock has 8 megahertz. And after this, we need also to set the multiplication factor that our PLL will have. So in this case, let's multiply by 8. Here in these three lines, we are setting the HSI as the PLL clock source, and we are multiplying the PLL clock by 8. Another thing about choosing the HSI as the clock source for the PLL is that when we are choosing the HSI, the value of the HSI is divided by 2, as we can see here in the documentation. So keep in mind that since the HSI is 8 megahertz by default, when we set to be the clock source for the PLL, the value will be divided by 2. Now we need to turn on the PLL clock, and we need to wait until it gets ready. So these two lines do the job. So now all we need to do is to choose the PLL clock to be the frequency clock coming from the main clock output pin. So here the value to do this underlines 50 and 51. And again, you need to check your data sheet to see if the value for your microcontroller are the same. So now let's flash and see the results. So here we are getting 60 megahertz. The reason for this is that we choose the HSI to feed the PLL. When we do this, the value of the HSI is divided by 2. Then we have 4. Then in the code we multiplied the PLL by 8. Then we have 32. And in the main clock output, when we choose the PLL, the value is divided by 2. Then we get 16. So that's it for now. Thank you for watching.